answer. Raj Kumar, if you are the same Raj Kumar, welcome. Sergey Zhuchkov, also welcome to our webinar. Nice to see you in the list. We will start in about 2 minutes. And I see that we are already live on YouTube. So if you have some interesting questions, you can prepare or post in advance on YouTube. I will be happy to answer. I think we can start.
Hello and welcome. We are so excited for you all to join us. This is our version 22.01 release, the first release of the new year. And Alexey Milovidov will be presenting today on all of the features that we're so excited to show you. And Christoph will be answering our Q&A, so keep those questions coming. Alexey, I'll hand it over to you.
Thank you. Thank you for the introduction. Let me share my screen, my presentation. So I will tell you what is new in our first release of this year, 22.1. I will spend most of the time for my presentation, and we will have around 20-25 minutes for your questions. So this is the first monthly release of this year. It has changed major number from 21 to 22, but don't worry, it is fully compatible with 21.12. The first number is just a year. So now we have the new year and the new release. We have our public roadmap for this year, and we already started delivering new features. Let me show what new features we already implemented from the roadmap. And let's start with something fairly simple: format auto detection. So when you write select query and you want data in some specific format, you have to specify this format like this: format CSV. If you did not specify a format, it will be tab separated by default in batch mode or in HTTP interface, and pretty formatted tables in a ClickHouse client. You can also use ClickHouse client to select data and save the result into out file like this. And in previous version, if you want to save like in CSV, you have to specify file name and also format. Now it is not required, and format will be auto-detected from file name. So you can just write select something into out file something.parquet. And it will be automatically written in Parquet format or CSV or JSON each row that is named new line delimited JSON, ND JSON, native format. If you write some file extension for compression like GZ, XZ, BZ2, or something like that, the file will be automatically compressed. And it also works for table functions and table engines. When you use file or URL, S3, HDFS, table engine, whatever, you don't have to specify the format, data format anymore if it can be automatically inferred from file extension. So pretty simple and good for usability. What else do we have? Now, the structure of some external data can be automatically detected from the data itself. If you have data in native or protobuf or Avro or Arrow, don't mess Avro and Arrow. These are different formats. Or Parquet or Orc. These data formats already contain data structure inside. So why should we repeat this data structure? Before version 22.1, if you want to query some data set from external service, like URL or HDFS or S3, you will specify the URL, the format name, and data structure. And table structure can be quite large, like this. This is huge, and it is painful to repeat it every time. By the way, look here. Since October or November or even summer last year, we have support for string literals in Postgres style, like this. Just write $2 or something in between $2, and it will be a raw string literal. Now it is much more simple. You don't have to write all this. Just write it like this. URL and the URL, and nothing else. Just one line. Data format will be automatically detected. Compression will be also automatically detected. And data structure will be automatically detected. Let's try. It should work. I have ClickHouse server already built and run on my desktop. So I can open ClickHouse client or ClickHouse local. Let me use ClickHouse local. It is quite interesting. I will shut down ClickHouse server and just run ClickHouse local in interactive mode. I will simply copy-paste this query and see what will happen. What do you think? Will this query succeed or not? Because live demos, you know, sometimes something breaks. Write what you think on YouTube or in Zoom chat. It should be interesting. Okay, let's try. It works. It works perfectly. And if I want to show what is the structure of this table, I can write just like this: desk or describe table. And here is the structure. Also, we have schema inference even for semi-structured and unstructured data formats like CSV, TSV, JSON, values, message pack, whatever. If you have data in JSON format, the types will be inferred like nullable of string or nullable or of float 64. The structure is automatically inferred from first lines of data. So let's also try and check how does it work. Let me show you some demo. I will just copy paste some comments. I want to be confident, so I will use copy paste. I like copying and pasting. So where it is? I created some data dumps in different formats: CSV, native, new line delimited JSON, and let me run ClickHouse local and check what is the data structure. So we have the file with 2 columns, user ID and URL domain. Both columns are string. Let me show you this file. Yes, it looks like new line delimited JSON. User ID is actually uint64 number, but it is inside string, so it is inferred as a string. Because if it will be float 64, then uint64 numbers will be incorrectly rounded. So it is much better to have these numbers inside strings in JSON. We also support arrays, even multidimensional arrays, even arrays of different types. And let me show you more examples. So what will happen if we have multidimensional array? Now let me copy paste these examples and we will see. The type is correctly inferred as array of nullable of floating point 64. The next example is more tricky. We have, let me show you. We have array of different types: integer, string, and another array of string. What type will be inferred? Let me check. Now it is inferred as tuple. What will happen if we have multiple JSONs with different structure, like this? One JSON has a field X and another field Y. So let me check. It will work like this. Missing fields will have value null, and this is why the types are inferred as nullable. And another example, I will try to make something really complicated and unusual. So in first element, it will be two-dimensional array of different types. And in second example, it will be also different types and a different number of elements. And if I will try this query, what will happen? It will just show you an error that the type cannot be inferent because it is different in different records. Okay, this is how type inference works for JSON. What if we have CSV or TSV? In CSV, if data is inside quotes, it will be inferred as a string. If it is a number, it will be float 64. For TSV, tab separated everything will be as a string. And column names will be automatically selected as C1, C2, etc. If you use CSV with names or TSV with names, then column names will be also extracted from header. So if I use a CSV file without headers, it will be just columns C1, C2. If I use some file with headers, now I specified data format explicitly, then column names will be inferred. So if you don't like to have all the columns as strings, we also support schema on demand. So you can specify data types explicitly on select. You can run the query as is, but the types will be just strings. You can specify explicitly that some column is actually uint64, and it will work more efficient. It will give you the result that you expect. What else? As a demo, I will show you how to use one less known formats like line as a string and row blob. Let me copy paste these examples. In this example, I will read my favorite website, Hackers News. I will read it with ClickHouse. So I will query it with URL table function. It will get HTML, and I will parse HTML directly with ClickHouse. ClickHouse can parse HTML. Okay, what are the news today? Something about Go and JS. What is it? DynamoDB. No, I will not follow these links. I will not waste my time on this webinar. But I can spend a lot of time. I don't actually like to read Hackers News with my web browser. I like to do it with ClickHouse client. And this is how line as a string format works. I can show you the structure of the result. So the inferred structure is just one field with name line and type string. What if I will use a format row blob? What is it? The format row blob will read all the data as one record with one field of type string. So get everything as a single string. What else? If we have some formats with external schema, like protobuf and capnproto, in these formats, the data itself does not have the information about schema. The schema should be provided from the outside. And you can specify the schema with a setting format schema with some path to the file with protobuf or capnproto schema and the name of root message. It will also work. You don't have to repeat the schema somewhere here. The types will be automatically inferent with a selection of the most near data types in ClickHouse. And finally, you don't have to specify schema when you create merged, distributed, or replicated merge tree tables. So when you create the first replica, you will write something like this with full schema. But when you create a second replica or third replica, you can write just like this. Create table without the schema. Just specify the engine. It will go to another replica, extract the schema, and copy it for you. The same for distributed table. When you create the first when you create the table on chart, you will specify the structure. But when you create distributed table, you will just write create table without schema. It will go to the chart, extract the schema for you, and that's it. And the same for merge table. Sounds cool, right? So this is everything about schema auto detection and schema inference. What else do we have for usability? Real-time resource usage in a ClickHouse client. So you want to run some query, and you want to know how much memory is being used, how many CPU cores is consumed. Let me show you how it works. Now I will run ClickHouse server. Here it is. Let's run ClickHouse client and run this query. It will use our public demo server with example datasets. I will run some quite complicated query that will calculate how many distinct issue or pull request titles are on GitHub. Probably 100 million. Let me check. Okay, here I have my favorite green progress bar. And where is the resource usage? Let me check again with a small font size because it has to fit somewhere here. Okay, here it is. 20 CPU cores and 5 gigabytes of memory, 7 gigabytes of memory, 10 gigabytes of memory. And if multiple servers are participated in distributed query, it will show you two numbers. memory consumption in total and maximum memory consumption per host. I have two ClickHouse servers, so ClickHouse client is connected to ClickHouse server on my local machine, and this ClickHouse server connects to another ClickHouse server, remote ClickHouse server with remote secure table function. So you can see resource usage like 31 CPU core is being used, and also I have timeout with 60 seconds on this public instance, so the query is not finished. But the purpose is to just show you this quite interesting feature. It looks small, but to implement it, we have to implement all metric forwarding from every server to every another server and to the client. Now client can easily display this resource usage. What else? Parallel processing on replicas. So ClickHouse is distributed massively parallel processing database. When you do distributed query, it is processed in parallel by multiple CPU cores and by multiple shards. Everything in parallel. But by default, it is using only one replica on every shard. Some people know that we already have the setting named max parallel replicas. For this setting to be usable, you have to specify sampling key, and it is quite difficult to use. You have to carefully choose appropriate sampling key, and it is not easy. Most of the time, it will not parallelize your query across replicas. So this setting is not good. But now we have something more interesting and more efficient. You only have to enable this experimental setting. Allow experimental parallel reading from replicas. So this is what is new in version 21.22.1. If you activate this new parallel algorithm, every replica will select the work dynamically. It will ask the initiator server about some chunk of work, and initiator will assign these chunks of work to every replica. And what is good, it can work even if replicas are not uniform. If one replica has more computational resources, another replica can be slower, but it will still participate in workload and just select less amount of work to process. Also, if some replica has delay, this parallel processing algorithm will select the most fresh available data. So it can use different replicas efficiently and consistently. This is experimental algorithm. I appreciate if you will try and share your experience. What else do we have for replicas? Now we have service discovery, automatic service discovery. If you want to configure the cluster inside ClickHouse, now you have to go to every ClickHouse instance and update configuration about clusters in remote servers. Now it's not necessary to update configuration on every server because replicas can automatically register themselves. Just enable service discovery. And for cluster, instead of writing every replica explicitly, just specify the path for service discovery. And you can specify a shard number, so the cluster will be automatically formed from every registered replica. So it is quite good for operations for usability. If you like this feature, please write a comment on YouTube. And I will know that if the author developed this feature, not for no one, but at least for you. Please write your comments and thoughts. What do we have for performance optimizations? Sparse encoding for columns. It is typical that you have multiple columns in your table. At least ClickHouse is column-oriented database, and you don't have to worry if you have hundreds of columns, sometimes even thousands of columns. But you may worry what will happen if most of the columns will have most of the data, just zeros, or empty strings, or just default values. You don't have to worry. Data will be compressed. Data will be decompressed on the fly. Queries will work. Queries will work quite efficiently. But now we also have something more advanced. What if we will automatically use this information for calculations? We will store data in special sparse format, and we can process this data without full decompression. We can run our functions directly on compressed data, and we don't have to recalculate function again and again on top of just zero value. To enable this feature, you have to specify this setting in creation of merge tree table. It is somewhat similar to low cardinality data type, but it works completely transparent and automatic. The types will be the same. It will automatically estimate should it use a sparse format or full format. It will be estimated for each data part. It will be re-estimated during a background merge, and queries will be optimized. How the queries will be optimized? Let me check. I will also copy-paste some examples. Here are my examples. First, I will create a table similar to test.hits table with the same structure, but with this setting. Table already exists because I already prepared this example. I will insert some data like this, but I have the data already inserted, so I will not repeat this query. let me check how the columns are compressed. I will select from system.columns for both tables hits and hits underscore sparse. For some columns, by the way, these tables are about page views for web analytics. And I have some columns about UTM tag. If you work somewhere about web analytics field, if you process clickstream or advertisement data, you already know what is UTM tag. If you don't know, don't worry. It is just some string column. And you see that data is compressed slightly better. So UTM campaign is compressed 2 times better. UTM content is also 2 times better. But if you look at uncompressed size, it will be about 7 times better. Because uncompressed data is actually still compressed because it is in sparse format. How does it affect performance? Let me check with ClickHouse benchmark. First, I will run this aggregation query and filtering query from test table without sparse encoding. Okay, it is quite fast, and the median time is 7 milliseconds. The minimum time is also 7 milliseconds. What will happen if I will replace hits to hits sparse? Something wrong happens. Oops, it does not work. Why it does not work? I should ask the developer. Who is this lucky developer? No offense, no offense. This feature, you see, it is quite experimental. Let me continue my experiment. I want to reproduce some claims about performance, even if it's not production ready. I will still try to reproduce, and we will check how it will work. So let me first drop this unfortunate table test hits underscore sparse. Okay, I will recreate this table. And reinsert data. What do you think? If I will recreate this table, will it show some performance benefits? Or maybe I will see some exception message. What do you think? Please write your comments. And by the way, for the best comments and the best questions, we have t-shirts. And we deliver these t-shirts basically to every place in the world, including the United States, Europe, China, Middle East. Okay, data is inserted. I will also try to optimize this table for the best performance. It should spend around 10 seconds. Here is the progress in server log. Okay, 12 seconds. And let me just try again. Now it works. And the median is 5 milliseconds. It was 7 milliseconds. Now it is 5 milliseconds. I have won 2 milliseconds. 2 milliseconds. It is fantastic. Now the query is optimized. And I'm very happy that it works, at least from the second time. And before using this feature, you have to wait for the next release 22.2. Don't use this feature in the release 22.1. It is not ready. But it is quite promising. Let's continue. It was the demo. Another quite interesting feature is the diagnostic tool. So if you want to ask for support about your ClickHouse instance, you should collect some information about what tables do you have, what features do you use. If the server is loaded, you want to dump the information from process list. Probably you want to dump some information from query log. And to do this, we used our diagnostic tool. It was developed for Yandex Cloud and inside Yandex Cloud. And now we decided to make it open source as a gift. Now it is available in our repository inside utils ClickHouse Diagnostic. It is just one script, one file, Python 3 script. You have to install some dependencies and run it. It will collect all the diagnostic report. You can just send this diagnostic report to your favorite support provider like Yandex or some other provider. Also, we started, my colleagues started to port it to Go to allow single binary distribution. It will be even more convenient. Maybe we will also implement it directly inside ClickHouse. So you will just write ClickHouse support and it will give you a report. We'll see. What about the new integrations? We have plenty of integrations like S3, HDFS, ODBC, JDBC, and now we have even more. You can directly query Hive tables. You can use Azure Blob Storage like S3 Object Storage for your merge tree tables. And now you can query data in HDFS in parallel from multiple servers in your cluster, similar to S3 cluster. About aggregate functions. Now we have several new statistical functions about Kramer's V value and Thiel's U value. Probably you don't know what it is. I already forgot what it is, but doesn't it sound very clever? The names are very, very clever, and probably Kramer and TL are very clever people. And these people looks like contributed these functions to ClickHouse. No, actually, different people contributed, but these people invented. What it is like correlation, but between categorical values to calculate dependencies. So if you have some field like URL, and you have another field like URL domain, and you have almost functional dependence, so domain is calculated from URL, almost always. This value will be close to 1. If it is not the case, the value will be lower. It is very useful for exploratory data analysis. When you have some data set, you don't know anything about this data set, you want to just explore it. Okay, enough for 22.1. What is next? What will be in the next release in February? First, about ClickHouse built for ARM, ARM64 architecture, also named AArch64. By the way, ClickHouse has been built for ARM already more than 5 years ago, even before open source. And we have already tested ClickHouse on plenty of ARM servers like Cavium, Huawei, Graviton, Ampere, and desktops and notebooks like Apple M1, Pinebook, and even Raspberry Pi, and even on mobile phone. So we know that ClickHouse works. And performance on servers is quite good. But we need more. We need full test coverage, 100% of green tests. Now we have 99% of tests passing. It is not enough. We also want to make release builds with Debian packages and Docker containers. It is already prepared and will be available starting from the next release. And what is missing is full support for big integers, base64 encoding, and JSON functions. In the meantime, people already use ClickHouse on production on servers with AArch64 CPU. We will also introduce some advancements for resource management, like flexible memory limits. We will introduce the cache, some cache for remote file system, some advancements for SQL compatibility, and some functions for text processing, like charset and language detection. And please read our roadmap. It is open. We have open roadmap. It is open for discussions, and all the great stuff is discussed there. Don't miss this great stuff. And we have about 10 minutes for questions. Thank you for listening. I'm ready for your questions.
Thank you, Alexei, for taking us through this. There are a lot of questions. I think I have over 25, so we'll see how many we get through. I tried to group them by topic, so we'll go in the order of what was presented. So first, a few questions on format auto detection. A question from Michael in Zoom. Would schema inference work to help confirm we have a column in the optimal format, for example, running the inference on an existing table?
if you have existing table, the schema is already inferred. It is already saved for this table, and you cannot change this schema. So you have to do schema inference before in advance. For example, you can create a table or use a table function with a file or URL engine. Some schema will be inferred. You can check this schema with describe command, and you will figure out if this schema optimal or not. If it is optimal, you can create the final table like merge tree table with the optimal schema, or you can or if you will find out that the schema is not optimal, like some data type is inferred as a string, but you want integer, you can just copy the schema from describe and adjust this schema and specify it explicitly.
Thanks. Question from Andre. Will describe URL read all the data to infer the schema?
No, it will read only some small amount of data. And it works in a quite interesting way for some data formats. So if it is like CSV or JSON, it is easy. You just start reading the data, you read like 100 of first records, and you will infer the schema. If you have data in Parquet format, the schema definition is actually at the end of this file in the trailer. So ClickHouse will do a range request to read this trailer. It will get the schema, and it will do another request to continue reading from the beginning. So everything works. Your server only has to support range requests. And if you use S3, it is always supported.
A question from Ali. Can it also determine the compression codecs themselves?
First, compression format, like gzip, xzip, bzip2, zstd, it is automatically detected by file extension. If you have mydata.csv.gz, it will find out that it is gzip compressed CSV. Easy. About column codecs. No, column codecs are not detected. And if you want to automatically optimize your data per column, you cannot. You have to specify these codecs like delta or some more heavy compression like zstd of some level explicitly.
Two questions on CPU usage. Is the total for one shard or for all the shards?
For all the shards. If you are happy to use some cluster with 100 ClickHouse machines, and every machine has like 80 CPU cores, sometimes you will see that ClickHouse will use 8,000 CPU cores. And I want to actually see this number in ClickHouse client. It will be very exciting. I will even hold my breath while looking at this number. It should be absolutely exciting to see. I'm using 8,000 CPU cores to process your query.
If somebody has a really big cluster, take a screenshot, put it on Twitter. We'll like it and we'll reshare.
And we will send you a t-shirt for the maximum amount of CPU cores that you can achieve.
Great. A question from Andre. When you have the tracking of memory and CPU usage, can you introduce more fine-grained control of and restrictions of resource usage between users and roles?
Yes, we should do. This is one of the next tasks. First, we will start with fine-grained memory limits. Currently, we already have memory limits, you know, but it is not so elastic. I don't like the word elastic, by the way, but don't worry. You can specify like, I want memory limit 10 gigabytes, and it is 10 gigabytes by default. But what if you have 100 gigabytes free at this moment of time on your server? And you run just single query. Maybe it will be better to allocate 100 gigabytes unless there will be another query that also wants this 100 gigabytes. So this is the first. And the second step and another step will be for flexible share of CPU and I/O. Okay, next question.
Okay, on parallel processing for replicas, a question from Ali, does max parallel replicas work with distributed tables?
Yes, it works, and it will use max parallel replicas for each shard.
And a question from SD, how does parallel processing work when multiple shards are unavailable in a replica?
It will select maximum number of available replicas. For example, you have 3 replicas on shard. You specified max parallel replicas equals to 3, but you only have 2 replicas available, and third replica is down. Then it will only use 2 replicas.
And last question on this topic from Andre, how is the data partition selected for replicas?
It is selected dynamically by allocating some chunks of work, not very small chunks, not very large chunks. You can imagine it like this. Suppose you like cats, and you have 10 cats in your home. And these cats are very hungry. You only have one meal for these cats. So you want to feed these cats, you open a can, and 10 cats simultaneously will run and try to eat from this can, try to eat food. This is how parallel replicas work. If some cat is more strong and more aggressive and have more resources, she can eat half of the can, and 9 other cats can only eat around 5%. So this is how you can imagine parallel replicas. I hope my explanation is quite clear.
Thanks. On cluster discovery, how does cluster discovery correspond with the replicator database engine table? Is it just different ways to achieve the same goal?
Yes, you can specify cluster definition in old style explicitly, or you can load it from Zookeeper and also specify explicitly, but you can use cluster discovery. And replicated database can also work on top of this automatically defined cluster. And every member of the replicated database will automatically merge to the cluster and get all the table definitions and log and replay this log and recreate tables, and tables will be automatically replicated if they are replicated tables.
And a question on ARM support from Rim. Will we have Apple M1 stable support?
Yes, we will release Docker containers for our stable releases. And also binaries, binary builds. So you will be able to install stable version on your Mac laptop or Mac Mini.
Great. I know that we're at the top of the hour. There are a number of other questions, but I don't know if you have some more time, Alexei.
I have about 5 minutes.
Okay, then let's try to take a few more. A question from Mohammed. ClickHouse is the fastest database in the planet, but we need it on Windows.
The most easy way to use ClickHouse on Windows is to install under WSL, Windows Subsystem for Linux. It works. Actually, we don't have test coverage for WSL, but basically it is Linux on Windows. You only have to worry about the file system. File system can be slow. So you should try on your workloads. It will work. And for native Windows builds, we don't have, but most likely we will not have anytime soon, but we'll see.
Question from Simi. What is the best IDE that works with ClickHouse? And a couple of answers came in mentioning DataGrip, Tabix, dbeaver, Tablum. I don't know if you have an opinion, Alexei.
I have some opinions, but no strong preference. DataGrip works quite well. Tablum is quite new system. It is very interesting. It is also commercial. I spent only 5 minutes to check Tablum. Don't mess with it. Don't be confused with Tableau and Tabix. There are 3 different systems. And from my experience, after 5 minutes, it works perfectly. That is actually surprising because almost no system works perfectly when I try. I usually discover some corner cases and issues. About what else? So probably I will recommend DataGrip.
Okay. Question from Santosh. How can I handle deduplication in ClickHouse, and does it have any huge overhead?
There are 2 mechanisms of deduplication that you should be aware. First is deduplication on block level. if you insert batch of data into ClickHouse, into replicated merge tree, and if you insert a duplicate, exactly the same batch with the same number and order and content of records, it will be deduplicated. This is made specifically to enable consistent inserts when you can have connection loss and you don't know if the data was inserted or not. And you just retry the same insert. And if it was already inserted, it will be deduplicated. So you can have exactly once insertion of your data if you will be careful enough to make the same batches. Another mechanism is named replacing merge tree. It works on record level. It can deduplicate identical records, but it works in the background. It will deduplicate records during background merges. But the duplication is not guaranteed unless you run your query with select from table final. Final is the modifier after select from. Or you do optimize table final to get rid of duplicates. There is another mechanism named optimize table deduplicate that can also remove duplicates even from ordinary merge tree table. Okay, now probably this was the last question, and I have to select the best question. What will be the best question? Chris, do you have a preference?
Not at the moment. I have a whole list that that we can go through.
The most technically advanced question. The question that highlights that the user have pretty good production experience with ClickHouse. Something like that. Something that will definitely pay for our t-shirt. Maybe about parallel replicas.
Yeah, maybe the question about does it work with distributed tables, a good catch.
Okay.
Or when multiple shards are unavailable.
Yes, this question. So what is the name?
It's SD on Zoom.
SD on Zoom. Congratulations. But we will need to know the details about shipping address and so on. Please connect us in email or connect me in Telegram, and somehow you will have to prove that you are the author of this question. Okay, now that's it. Thank you for listening. Thank you for your questions. And I hope you will install and try our new release. See you in a month.